Okay, I mean, hold on. Let me close the door. Okay, I'm back. Um, Here we go. Now, so you take your mass of the entire thing, and now we got to find the moment of inertia, and that's how easily it wants to spin. Okay, remember mass is its inertia on how much force we need to apply to scoot the thing, whereas the moment of inertia I is how much torque, which is actually what you're doing with your finger. You're providing torque, which you can take my physics 210 class and find out all about torque, where I is equal to 1/6 times the mass that you got times r squared. So you go ahead and get that number. Now the fun part, now go out and toss your boomerang like 3 times, take 3 measurements, and you can, and r bar here means take the average. So what I'd like to see here is when you do this, here we go, let's go to this one so we can actually write on this. So to do this one, let's zoom in. Let's have the ladybug zoom in a little bit here. I think I can have her do that. Go here, and then this is the zoom in part. Does that work a little better? Oh, there we go. And then let's make this big again. There we go. All right, so now, so R bar means the average. That R, so take your, throw it 3 times or more if you want, and then take measurement 1, measure 2, measure 3, add them up, plus, equals, divided by 3, and that is equal to your R bar, okay? Let's see. Now, you got to calculate the coefficient of lift of your boomerang. Hold on to your hat, solve the equation for R for, in other words, here's the equation to find the radius if you know the coefficient of lift. As good scientists, we're going to try and figure out what the coefficient of lift is. Okay, so what are the elements that we need? Let's just take a look at this real fast. So we need R is equal to 4I. Let me write down the equation here. R is equal to, and this is the R bar that you got, is equal to 4I divided by pi, because things are going in a circle, can't get rid of pi, CL times the density of air, that little rho is the density of air, times R to the 4th. Okay? The little r above is the radius of your paint stick. Paint stick radius. Okay? So how do we tease that CL out of there? I should. This is a thing I give to upper level classes or to, and I hate saying that because that makes it sound like, oh, I don't give this to dummy. I'm just saying, I give it to people who have taken a lot of algebra, probably some calculus and things like that. So when you say, hey, solve for CL, they just automatically know what to do, all right? Because that's what they're trained to do, all right? And so it's no shame, but we get to do something if this scares you. It is okay. Just remember, rho, we're going to say is 1.29 kilograms per meters cubed. Okay, and R is the radius of your paint stick that you got, this R. Okay, and I, you measured. And now we're going to find CL of your paint stick based on your R, which you measured. Okay, you measured that, and now we're going to find CL. And it's pretty simple. I'm just going to write it out for you because basically what I would do is you take multiply CL by both sides. So you get CL times R is equal to 4I CL, because I got to multiply it over here, divided by pi CL rho little r to the fourth. Okay, now we've got to find CL. So now we'll divide by r. So look what happens. The CL disappeared over there. Yay, team. Now, divide both sides by r. So you get CL r over r is equal to 4i. Since we put r below the line, we're going to put it below the line here. Pi r rho, which is your density of air, times your r to the fourth. Okay? And then that cancels. And then you've got your r down here. And this r, remember, is your r bar, which you measured earlier. It's your r bar that you measured. Okay, so now you got the CL of your boomerang. All right, got this. So now that will not change because we're going to assume the flight and everything is going to be about the same, and so that will not change. And I'm going to stop here, and we're going to go on to the next track for this. This is a hell of a lot more involved than I thought it was going to be. Jiminy Christmas! But I still want you to have fun with it, damn it. All right.